Our solar system, a tiny corner of the vast cosmos, is a cosmic symphony of planets, moons, asteroids and comets, all bound together by the gravitational embrace of our star, the Sun. It is a place of unimaginable beauty, mystery and extremes, a place where the story of our planet, our existence and perhaps even our future unfolds. Today, we will embark on a journey through the solar system, exploring its origins, the unique characteristics of each celestial body, and the ongoing scientific discoveries that continue to reshape our understanding of this intricate and dynamic system. The birth of the solar system. The story of the solar system begins about 4.6 billion years ago in a vast cloud of gas and dust known as a molecular cloud. This cloud, rich in elements like hydrogen, helium, and heavier elements forged in ancient stars, began to collapse under its own gravity. As it did, it formed a rotating disk with a dense core at its center. This core would eventually ignite to become our Sun, a star powered by nuclear fusion, providing light and heat to the planets that formed from the remaining material in the disk. These planets, along with moons, asteroids, and comets, coalesced from the dust and gas, creating the diverse and dynamic system we observe today. The solar system's formation was a chaotic and violent process, marked by collisions, accretions, and the migration of planets. Over time, however, it settled into the relatively stable system we know today, with the Sun at the center, surrounded by 8 planets, their moons, and countless smaller objects. The Sun, the heart of the solar system. The heart of the solar system lies the Sun, a glowing sphere of hydrogen and helium, a middle-aged G-type main-sequence star that accounts for more than 99% of the total mass of the solar system. The Sun's immense gravitational pull holds the planets in their orbits, while its radiant energy powers the processes that sustain life on Earth. The Sun is a dynamic and complex object. Its surface, known as the photosphere, is constantly roiling with activity. Sunspots, solar flares, and coronal mass ejections are just some of the phenomena that shape the space weather affecting our planet. Beneath the photosphere, the Sun is divided into layers. The convective zone, where energy is transported by convection currents. The radiative zone, where energy moves outwards through radiation. And the core, the Sun's powerhouse, where hydrogen nuclei fuse to form helium, releasing energy in the process. The Sun's life cycle is a testament to the interconnectedness of the universe. Born from the remnants of earlier stars, it will one day expand into a red giant before shedding its outer layers and leaving behind a white dwarf, a final chapter that will have profound consequences for the solar system. The inner planets, terrestrial worlds. Moving outward from the Sun, we encounter the inner planets, Mercury, Venus, Earth and Mars. These 4 worlds, known as terrestrial planets, are characterized by their rocky surfaces and metal-rich cores. Each planet has its own unique story, shaped by its proximity to the Sun, geological activity and atmospheric conditions. Mercury, the smallest and innermost planet, is a world of extremes. It experiences the most significant temperature fluctuations in the solar system, from scorching daytime heat to freezing nighttime cold. Mercury's surface is heavily cratered, a testament to its ancient history and the absence of a protective atmosphere. Next is Venus, often called Earth's sister planet due to its similar size and composition. But beneath its thick, toxic atmosphere of carbon dioxide, Venus is anything but Earth-like. The planet's surface temperature is hot enough to melt lead, and its atmospheric pressure is crushing. Venus's runaway greenhouse effect offers a stark reminder of the power of atmospheric change. Then we come to Earth, our home, the only known planet to harbor life. Earth is unique in the solar system, with liquid water, a stable climate, and a protective magnetic field. Its atmosphere, rich in oxygen, supports a diverse biosphere, while its geological activity constantly reshapes the planet's surface. Earth's story is one of delicate balance, with life playing a crucial role in maintaining that balance. Finally, we reach Mars, the red planet. Mars is a world of contrasts: dry, dusty deserts and towering volcanoes, deep canyons and polar ice caps. Once a wetter and warmer planet, Mars's climate changed dramatically, leaving it cold and barren. Yet, Its past has left tantalizing clues that suggest it may have once supported life, and it remains a prime target for exploration in the quest to understand our own planet's history. The asteroid belt, a frontier of small worlds. Beyond Mars lies the asteroid belt, a vast region filled with countless rocky bodies, ranging in size from tiny pebbles to the dwarf planet Ceres. The asteroid belt is a remnant of the early solar system, a place where planet formation was disrupted by the gravitational influence of Jupiter, leaving behind a collection of primordial objects. Ceres, the largest object in the asteroid belt, is a fascinating world in its own right. Though classified as a dwarf planet, Ceres shares characteristics with both asteroids and icy bodies in the outer solar system. Its surface shows evidence of water ice, and recent discoveries suggest the possibility of a subsurface ocean, raising intriguing questions about the potential for life in unexpected places. The asteroid belt is not just a relic of the past, but also a frontier for future exploration. These small worlds hold clues to the solar system's formation and evolution, and they may one day provide valuable resources for human space exploration. The outer planets, giants and moons. Moving further out, we encounter the outer planets, Jupiter, Saturn, Uranus and Neptune. These gas giants and ice giants are vastly different from the terrestrial planets, with thick atmospheres composed mainly of hydrogen and helium and no solid surface to speak of. Their immense gravity shapes the orbits of their many moons, rings and other objects in the outer solar system. Jupiter, the largest planet in the solar system, is a world of superlatives. Its iconic Great Red Spot is a colossal storm, larger than Earth, that has raged for centuries. Jupiter's magnetic field is the strongest in the solar system, trapping charged particles and creating intense radiation belts. But perhaps most intriguing are its moons, especially Europa, with its subsurface ocean that may harbor life, and Ganymede, the largest moon in the solar system, with its own magnetic field. Saturn, known for its stunning ring system, is a gas giant that has captivated human imagination for centuries. Saturn's rings are composed of countless ice particles, ranging from tiny grains to boulders, each orbiting the planet in a delicate dance. Saturn's moon Titan, with its thick atmosphere and lakes of liquid methane, is one of the most Earth-like worlds we've discovered, though in a frigid, alien way. Uranus and Neptune, the ice giants, are mysterious worlds with deep, cold atmospheres and strange magnetic fields. Uranus, tilted on its side, has seasons that last over 20 years, while Neptune, the farthest planet from the Sun, hosts some of the fastest winds in the solar system. Neptune's moon Triton, with its geysers of nitrogen, hints at a complex and active interior. The outer planets are not just giants in size, they are giants in their potential to teach us about the formation of planetary systems, the behavior of atmospheres, and the possibilities of exotic forms of life. The Kuiper Belt and beyond, the edge of the solar system. Beyond Neptune lies the Kuiper Belt, a region filled with icy bodies and dwarf planets, including the most famous of them all, Pluto. Once considered the 9th planet, Pluto was reclassified as a dwarf planet in 2006, a decision that sparked much debate but also deepened our understanding of the solar system's diversity. Pluto, with its complex surface of mountains, plains and glaciers, is a world of surprises. The New Horizons mission, which flew by Pluto in 2015, revealed a landscape far more varied and dynamic than anyone had imagined, including evidence of cryovolcanism and a tenuous atmosphere that changes with its seasons. The Kuiper Belt is home to many other fascinating objects, such as Eris, Haumea and Makemake, each with its own unique characteristics. These distant worlds are remnants of the early solar system, preserving conditions that have remained largely unchanged for billions of years. Even further out, beyond the Kuiper Belt, lies the hypothetical Oort cloud, a vast sphere of icy bodies that marks the boundary of the Sun's influence. It is from this distant region that long-period comets are thought to originate, bringing with them material from the very edge of the solar system. The future of the solar system and humanity's role. The solar system is not a static place, it is dynamic, constantly changing and evolving. As we look to the future, Humanity's role in this vast system will be defined by our continued exploration and our ability to harness the resources and opportunities it offers. Mars is the most immediate target for human exploration, with plans for crewed missions in the coming decades. Colonizing Mars could be a stepping stone for humanity to become a multi-planetary species, ensuring our survival in the face of potential Earth-bound catastrophes. Asteroids and the moons of the outer planets may offer resources that could support future space missions or even provide the raw materials for building space habitats. The icy moons of Jupiter and Saturn, like Europa and Enceladus, could harbor life, and exploring these worlds might answer one of humanity's most profound questions: are we alone? Meanwhile, missions like the James Webb Space Telescope and the search for exoplanets in other star systems will continue to expand our understanding of planetary systems, both within and beyond our solar system. But as we explore, we must also recognize the need to protect and preserve the solar system. The threat of space debris, the ethical considerations of planetary protection, and the long-term sustainability of space exploration are challenges we must face as we venture further into the cosmos. The solar system is our cosmic neighborhood, a place of unparalleled diversity, beauty, and mystery. It is a place where the forces of nature have sculpted worlds of every kind, from fiery infernos to icy wastelands, from rocky planets to gas giants, from tiny asteroids to distant dwarf planets. As we continue to explore and study the solar system, we deepen our understanding of the universe and our place within it. We are part of this cosmic system, shaped by its forces and its history, and our future is inextricably linked to its fate. Thank you for joining me on this journey through the solar system. If you enjoyed this exploration, please like, subscribe, and share your thoughts in the comments below. Until next time, keep looking up at the sky and wondering about the wonders that lie beyond.